Hello everyone, welcome to day 18 of competitive programming. Today I will be solving yesterday's questions where we have left over. In practice, it was like maximizing the mix or equal mix splitting. Yeah. So they will be giving an array, and okay, let's open our terminal. I forgot to start the timer, and now change the CP. Let's open the file mix split. So we need to say how many arrays we can create with equal max. That is the question. So let's read the question one more time. Chef has an array of length n. Chef wants to select some disjoint non-empty subarrays from A such that the max of each of the selected subarrays is the same. Note that the selected subarrays need not cover all the elements of the array. For example, A is a given array, then one way in which Chef can select subarrays is as 0 1 1 3 0. Both of them is 2. Now the max is 2. Next, an array X is called. Okay, Chef wants to select the maximum number of disjoint non-empty subarrays that satisfy the above condition. Can you help him to do so? Next, here it is given a note. An array X is called a subarray of an array Y if X can be obtained from Y by deletion of several, possibly 0 or all elements from the beginning and several possible 0 or all elements from the end. So the point is we can remove elements from the starting, from the ending. We cannot remove the elements from the middle. Or like if array given is 1 2 3, we cannot remove 2 and we cannot say 1 3 is a subarray. Okay, max of a subarray is the smallest non-negative number that does not occur in the subarray. Okay, here he has taken 0, next is 0 3 and 2 0. Okay, I'm thinking that we'll maintain a max value and we'll take the for loop and we'll calculate the first element max and next two elements max. If it is equal to the first element's max, then we'll increase the counter. So in that case, here 0 max is 1, 0 1 max is 2, so we cannot increase the counter. 0 1 1 max is also 2. So like I am thinking is we can solve this question in order of n by maintaining one for loop from 0 to n, and we'll check if any element in the array is 0, then we'll increase our answer. Like if it is 0, like here this is having 0 and this is also having 0, so answer is 2. In this array we are having 3 zeros, so answer is 3. So we can take 3 arrays from the 0, starting from 0. If 0 is not present, then max will be 0, right? If we start from 1 and 2. Okay, based on that logic, we'll simply take a for loop. And here we'll be saying if any array element is equal to 0, then we'll increase the answer. Okay, we'll maintain a variable answer equals to 0. And at the end, if we are able to create arrays using 0, whose max is equal, if that value is greater, we'll print it. If not, without using 0, if you are making arrays, we need to have that also, right? So answer is equals to maximum of answer and n minus answer, like n is the size of the array, right? If without using zeros, if you are making any arrays, we are printing that. Let's print the answer. Let's compile now. Okay, max split. Copy all this. We got the answer 6. Okay, sorry, we got 2 and 3, right? Yeah, here it is working. Let's submit this. Submission queue. Currently running test case 4. Did it get submitted? Okay, we are having level string. Yeah, it got submitted. It's the correct answer. So since we have solved those 2 questions, now let's decide what type of questions we want to solve now. Shall we solve greedy algorithms or binary search? In binary search, in our level, we are having 2 questions. But these are 12 underrated. And in greedy algorithms, at our rating, okay, did I apply a wrong filter there? Yeah, I guess I have applied a wrong filter here. Okay, there are actually none. So let's solve questions based on greedy algorithms. And let's solve this question. Let's close this file and let's create a file vcouple.cpp. Okay, now there are 2 groups, one of n boys and the other of n girls, numbered from 1 to n. You are given 2 arrays A and B containing n numbers each, denoting the height of boys and girls in the group. You have to perform n couples. You have to form n couples, where each couple will consist of 1 boy and 1 girl. Each couple has a likeness value, where likeness value is equals to height of girls in the couple plus height of boy in that couple. You have to perform n couples in such a way that the maximum of value of all the couples is minimum. Okay, it should be minimum. Can form more than one couple. Okay, we actually understood the input, but we are not taking the array. For each test case, we'll be having. Okay, we'll be having two arrays. One for boys and one for girls. Let's take this as base to not confuse. The height of n girls. So here ai and bi values is 10 power 9. So adding them, we need to take long. N value is up to 10 power 4, so it's no problem having it as int. So here you can form couples of boys and girls with index pair 1 and 1, which is 4 plus 2 is 6, 5 plus 2 is 7, 1 plus the maximum value will be 7, and there are no other ways that can minimize the maximum value 7. So I'm thinking you'll sort one array and you'll sort other array in reverse order so that you can add maximum number to the smallest number. That's it, right? Sort sort the first array b comma b plus n in normal way. Boys will be in normal way. That means increasing order. And the next array will be solving in decreasing order. Now let's take a for loop. Let's maintain a variable answer whose value is 0 currently, and now we'll take a value and we'll add first, that means smallest height from the first b array to the greatest height in the g array. Now we'll say answer is equals to max of answer and value. Okay, we need to minimize the maximum value, right? I guess there is no other way. The way we are thinking is we'll add if we add any other number to the maximum number other than, like let's say if one array is 1 2 3 4 5 6 7 and the other array is 7 6 5 4 3 2 1. Okay, now let's take, here we'll take all the even numbers for the boys array 2 4 6 8 10. Here all the 9 odd numbers 9 7 5 3 1. So here 10 plus 1 is level, 9 plus 2 is also level, 6 plus 5 also will get level, 7 plus 4 we are getting level. So this is the only way I'm guessing. Let's take for the given input 4 5 and 1, 2 and 2 and 2. If we sort it, we'll be getting 1 4 and 5. 5 plus 2 7, 4 plus 2 6. Let's take another values. Let's take 3 6 8. But if we are sorting in reverse, will be in this way, right? 8 plus 1 is 9, 4 plus 6. So here instead of doing 4 plus 6, we can do 3 and 6. So actually this way doesn't work. You cannot solve it in n square, right? Or can you do it in n square? 10 power 8. No, you cannot do it in n square. 4 into 10 to the power of 8. Only 10 power of 8 operations are allowed. Hmm. If it is n square, then we'll take the one value, and we'll check by adding all the values in the second array, and in which we are getting minimum, we'll add that one. But what if some other numbers need the minimum value? Test cases are only 5 test cases. This approach will be failing, I guess, because in middle there may be two numbers, like if it is 1, there may be 6 here and there will be 9 here. Here the maximum value is maybe 10 and the middle value may be 9 and the other value may be 1. So here we are getting 6. Okay, let's take this 7. 10 plus 1 is 11, 9 plus 6 15, 7 plus 1 is 8. So instead of adding 9 to 6, we can add 1 to 6, and adding 9 to 7 is a good way. Okay, let's do this. That's the answer, and we'll print the answer. Let's compile, copy all this. We got 7, but will this get submitted is the question. My point was, like, if there is a value which are adding to them. Okay, it got submitted actually. Wow, I was thinking something else. Like if 1, 4 and 9 are present, and if 8, let's say 5 and 1 are present, or let's say 7 and 1 are present. Yeah, you cannot do it. Actually, I was thinking, like, instead of adding 1 to 4, if it is 5 here, and if it is 6 here, 6 plus 4 is okay. If you add 6 to 5, the number will be increasing. Anyways, that is the solution here for the grid algorithm. We have finished it quite fastly. Next question is, say no to drugs. So autumn, no. Actually, we have solved this. I guess we have solved it in, let's see here. Yeah, I guess I remember solving this in a contest. Let's go to scripts, CodeChef and contest. Which contest is it? Not this. Anyways, I have solved this in some contest actually. Okay, it is not working. Yeah. Okay, now let's just see the question. Let's see the answer. First, let's read the question and then we'll go for the answer. I'll create a file here, no drugs.cpp. And let's copy the solution. Okay, first let's see the question. There are n people participating in a race. The nth participant is your friend, so you want him to win. You are not a man of ethics, so you decide to inject some units of a performance enhancement drug, don't ask where that came from, in your friend's body. From the charts you came to know the speed of every player. Formally, for a player I, his speed is denoted by SY. The change in speed Okay, the change in speed with 1 unit of the drug is k units. Note that k will be can be negative, which means the drug has more side effects than benefits. Of course, there will be a drug test before the race, so your friend will be caught if the number of units of drug in his blood is greater than or equal to L. You need to determine whether you can help your friend to win the race with or without drugs without getting caught. A player wins the race if he has the maximum speed among all the participants. If there are more than one people with the maximum speed, they tie at first place and no one wins. So input, we are taking T, N number of participants, K change in the speed by the drug, L minimum units of drugs that can be detected in the drug test, N space separated integers, and the speed of each participant, where that is the SI value. So we need to output yes or no. Let's copy all that and let's paste this, and let's see the solution, how we have solved this, and let's try to reduce it, clean it or make the code even more to look good. Is it hash define? Okay, hash type def long ll, or you can use hash define also. Okay, first of all, we are not using solve function, so let's use that. And instead of this, let's use a while loop. While t minus minus, let's call the solve function. Yeah, now it looks good. I don't know why I used capital letters here, but I did use them. So let's remove this and even okay. Now we are reading n, k and l values, and we are creating a vector A. Actually, yeah, the values are very less, so it's not necessary to use ll long. We can do with the int also. And let's remove all these unnecessary brackets. Okay, here we are reading the input, and if it is we'll also finding the maximum okay, we're taking the x. Here we are not reading all the values, we are only considering the values that are greater than the maximum. That means only maximum values we are pushing into A. So if the array is 2 3 2 1 3 2, 2 is maximum, so we'll push it. We need not care about 1. Since 3 is maximum, we'll push that 3. Again, we'll not care about 2. Okay, so that we found our maximum. We just found our maximum and we are pushing all the numbers to the array. We need not maintain this array, I guess, since we are not using x anywhere. Here okay, we did say x is equal to max. What is x here? X is the our friend's speed, right? His speed is the last one mentioned, isn't it? Mansra for the charts, k units. First line of input contains single enter t, number of test case contains 3 space hour, number of participants, change in speed, minimum units of drug there can be. Second line of each test case contains the speeds of the participants. The initial speeds are you can inject 1 unit of the drug into your friend's body and increase the speed from 2 to 4. 4 is the fastest speed. Thus you help, okay, in case 2. You can inject and to 4, but you cannot inject anymore. The third, note that impact of the drug in this case is negative. I guess the last value is the speed of your friend. Where did they mention that? Not speed of each player. Formally for a player I, his speed is generated by SI. The change in the speed 1 unit of drug can be negative, has side effects if it is negative. Of course, there will be a drug test before the race, so your friend will be caught if the number of units. A player wins the race if all the participants maximum. If any two players are having maximum speed, then no one wins. As I remember, the last element, the last value in the given array is the friend's speed. So since here the last one will be reading x, so we need not push x there. We'll be having x, and we'll compare that x with the maximum element. If our x is the maximum, then we'll just print s. Yeah, if it is not the maximum, we will check if maximum is greater than or equal to maximum of k into L minus 1. L is the number of units they can check. L is the number of units. If you inject L units, you'll get detected. So you can inject only L minus 1 units into k. K is the advantage of taking the drug. Plus x. We are doing plus x. So now by adding it, we are checking, is this necessary? STD max. Okay, we have created a variable max, so it is necessary. Here is a max function from standard library or from standard namespace. Okay, now we'll print no. If maximum is still greater than after adding the drug also, then we cannot help him. If it is not, we'll print s. So here instead of having this loop, you can just say if maximum is this is much better, right? If maximum is greater than, even after adding the drug, then we cannot do anything. So we'll print no. If it is not greater or if it is equal, then we'll print yes. If our x itself is the maximum, then in that case we'll be failing. So let's run this code. In this, we have only change we have done is we have removed the array. We are not maintaining the array. Yeah, we got the wrong answer actually. So we need to maintain the array. But I don't see any point in maintaining it. Yeah, we got the correct answer. Okay, what is happening if you're not maintaining the array? Let's remove the array and let's remove the a dot pushback. Now let's try submitting. Currently running test case 0. Yeah, still we got the correct answer. So it is not necessary to maintain the array. Okay, that's it. We are done solving those two questions. Maximum angriness. I guess we have solved two questions. No drugs is already solved. Okay, maximum angriness is the question. Let's close this. Autumn max angry.cpp. Okay, let's see the question. Alice and Bob are playing a game yet again, but this time Bob already lost the game. Now he wants to take revenge. Bob saw a jigsaw puzzle which has solved by Alice and decided to jumble the puzzle pieces again. There are n puzzle pieces in a line numbered from 1 to n in increasing order, and he has k minutes before Alice catches him. Bob can swap any two pieces of the puzzle. Each swap takes 1 minute, and so Bob can make at most k swaps. In AI, let AI denote the pieces in the ith position after Bob finishes making his swaps. Alice's angriness is defined to be the number of pairs such that AI is greater than AJ. Pairs I and J where AI should be greater than AJ. Bob would like to make Alice as angry as possible, so he asks for your help. If he performs his swaps optimally, what is the maximum angriness he can achieve? So what is the input here? Contains an integer denoting the number of test cases. The first and only line of each test case contains two space separated integers n and k, the number of pieces and the number of swaps Bob can make. So first one is say 7. So we took an initial arrange an array 1 2 3 4 5 6 7. Bob can make, okay, we need to reverse the array, that's it, right? The angriness of this sequence is, so if we take these two pairs, any two pairs, it will be equal. So this is addition of those numbers. 3 plus 5 plus 7 plus 1 plus 2 plus 6, it is 24. 2 and 6, 2 plus 6 is 8, 1, it is also 8, and it is also 8. Did you add any extra number here? 8 3s are 24, yeah. The angriness of this sequence is 21. This is the maximum possible. So no swaps can be made. The answer is always 0. Okay, we are just reversing the array. Bob can make k is equals to 3. Okay, number of swaps also need to be counted. So he will be swapping 2 and 6. Now the pieces are 1 6 3 4 5 2 7. Next swap is 1 and 7. Now the pieces are 7 6 1 2. And final swap is 3 and 5. Okay, 7 6 5 3 2 1. Okay, how did he get 21 is the question. Is defined to the number of pairs of I and J. Okay, here there are 21 pairs, are they? 7 6 1 pair. By the way, we cannot solve this question in even an order of n also. Wow. So 7 6 1, okay, 7 6 1 pair, 7 5 the other, okay, basically 1 and all other numbers are 1 pair, right? 3 4 5 6, so there are 6 right there. And if you take 6 and all other numbers also 1 pair, those are 5. And you can take 5 and all other numbers 3 4, and for 4 also 4 3 2 1, 7 6 5 4 3 2 1. 3 plus 2 plus 1. Yeah, it is the sum of all the rest of the numbers, or the number of pairs they can form. That means here n is 7, right? So it is the combinations formula. Hmm. So combinations are like 3 3 6 7, right? So if there are 7 values given and you need to take in 2 values, so it's 7c2, 7 factorial 5 4, okay, 7 factorial by 7 minus 2, 5 factorial into 2 factorial, so 7 into 6, 42 by 2 is 21. Should I write a function for factorial also? No. So how do you calculate factorial? Let's just say if a number is 8, you will just do it with 8 minus 2, right? So 8 into next number is 7, so it is just n into n minus 1, that's it. So okay, for now let's read the array. We are not reading the array, we are reading n and time t. We are having both of them. What if here only 2 is given? Then you can take 7 and rest 6 and the rest of the array. 7 rest of the array, 6 and rest of the array. What is 7 by 2 actually? 7 by 2 is 3. In int it is 3. So 7 float division is 3. So you only if you are having time which is half of the array size, then you can reverse the whole array. Then you can take n into n minus 1 divided by 2. That's the value of angriness you can achieve for the maximum. So let's do in that case. If that's not the case, then how do you do it? Like 8 and 2. 8 and 2 in the sense 1 2 3 4 5 6 7 8 That's it, right? And you're having only time to, so you can only change 8 and 7, 3, 4, 5, 6, 1, 2. So you can take 8 and the rest of the array. I should be less than and j, so 7 and the rest of the array. And you can take 4 and this element. You can take 3 and 1, 2, 4 and 1, 2, 5 and 1, 2, 6 and 1, 2. So basically here it is 8 and 3, 4, 5, 6, 7, right? So 7 plus 6. When it comes to 3, you can only take 2 values. So 2 values here, 4 2 values, 5 also 2 and 6 also 2. Yeah, you got 21. And for case 1, for 1 you cannot take. So the answer is 20. It should be 22 actually. Okay, 1, 2, 3, 4, 5, 6, 7. And 7 and 3 also 1, 2, 3, 4, 5 and 6. 3 and you can take 1, 3 and 2 also you can take as one pair. Those are 2 pairs. 4 and 1 as pair, 5 and 4 and 2 also as a pair. 5 and 1 as a pair, 5 and 2 also other pair. 6 and 1 as a pair, 6 and 2 also pair. So rest, and that means so it is basically n into n minus time, 2 times of time. So 8 into 8 minus 2 times of time is 4. These elements into 2, right? Into time, which is 2. So what is this value? You are getting 64. Divided by 8 is 8. So 8 plus, for first value there are 7 plus 6. You are getting 21, but the answer is 22 actually. Oh sorry, it is 2 and 1, right? My bad. I wrote it because you're swapping 8 and 1, so it is 2 and 1. So here we'll get one more pair actually. So 3 and 1 2 one pair, 4 2 and 4 1 other pair, 5 2 and 5 another pair, 6 2 and 6 1 other pair. So you are getting 22 pairs totally. So first let's solve for if t by 2 is t is equal greater than or equal to n by 2. In that case you'll take the array, you'll reverse the array, you are able to reverse the array, and you will get int answer equal to 0 initially. Now answer plus equal to n into n minus 1 divided by 2. That's it, right? So okay, now let's use exit function to exit. Now let's compile this max. Let's take all this values. I hope we'll get we got 21. Okay, for the values where t is greater than half of the n value, we are getting correct output 21 and 10. Now we need to output for here 1 comma 4. Why it is still 0? So because n is 1, right? So n into n, okay, that's why it is 0. Now else answer plus equal to the point is here what I'm thinking is you have 1 2 3 4 5 6 7 8, right? After swapping you will get 8 7 3 4 5 6 2 and 1. So you got n less than number of n minus 1 number of selections. You need to multiply, you need to add. So let's say for int I equal to 0, I less than n, I plus plus. Okay, I less than t actually. T is time here. Okay, let's take the variable called k, because they are saying k, but k value is 10 power 9, so you cannot actually go till k. You cannot use a for loop for k. You need to figure out yourself a formula. If it is 9, then this will be 9 8 and 3 4 5 6 7, and in this way. So you need to add 9 8, you need to also add, that's it, right? Okay, if you add next you need to add 7, because 8 into 7, 8 and 7 pairs. If k is increased to 3, then you need to add one more time. So can you say n into, sorry, n minus 1 into, here it is n is 9, right? Okay, let's go for 8 first. 8 minus 1 7, okay, you'll get 7 into n minus k, which is n minus k is 8 minus 2, which is 6. So this is wrong actually. Basically here you need to add numbers, you need to minus the n value, and you can minus it up to k times, but k can be 10 power 9, so it's not the you cannot use a for loop there. You need to find a formula for to do that. What is the formula? We are having 10 more minutes to do this. Hmm. I'm just thinking where there is like you got the point right. Okay, else I'm thinking like now the value is n, right? So how many times the value? Okay, we need to reduce it the time of given. Like if I say 8, then 8 minus, okay, twice of, because we'll not count these two things, right? These two and these two, like it's twice, right? If it is if n is given, k is given as 2, we are removing 4 from then, so we got actually these numbers into those values. I mean same here, what we are doing the same thing. That means if we are removing those 4, we have got 4. Now 4 for 4, if you'll do 4 into 4, 12, you'll get 12 selections here, because of for these things you'll get 12 selections, and for these things 9 into 8 by 2, 9 into 8, 36. So it's 36 plus 12, you will actually get 48. Is that correct? Let's clear and let's see one more time for 8 only now. So you'll get 8, no 4, right? So 8, and I mean like 8 minus 2 into, I'm trying to get a formula here, 2 into the value they got gave is k, so you'll get 4. Now after getting 4, for 4 you'll calculate, if you'll consider the array is having only 4 elements like 1 2 3 4, and you can reverse the array, so you'll calculate how many number of combinations you are having for that. That is 4 into 4 minus 1 by 2. Here based on associativity, you need to first multiplication happens, but we need minus subtraction to happen first. So if we perform this, we got 6. Okay, is this correct? Actually I guess we need to get 12, right? 12 by 2 is 6. Okay, we got 6 now. Anyways, we got 6 here. Now for 8, it will be like 8 into 7 by 2. We got 28 here. So 8 in 28, we got 28. 28 minus 6 is 22. Okay, actually we can do it this in this way actually, where we'll just calculate, we'll just consider we can reverse the array. Okay, we can just reverse the array, and we'll think if we cannot reverse the array, that means if k is less than n by 2, in that case we'll just remove the elements for which we cannot calculate, like for these 4 elements we cannot calculate, right? Okay, for here it is 5 elements, or like it's like if it is actually you can sort it, then you will be like 8 7 6 5 4 3 2 1. So here for every element you can take the elements less than those elements, but here for 3 you cannot take all the elements less than that. You can only take 2 elements less than that. Even that's the same thing for 4. So like that you will be having n into n minus 1 by 2 elements, or you will be having no, you will be having actually n minus 2 into k. That means here n will be equal to n minus 2 into k. Now you will be subtracting from the answer those numbers. For those numbers you cannot perform. So this is what the formula is actually. Now let's exit clear. Now let's compile. Yeah, it's working perfectly. Okay, now let's copy all this. Let's just paste, submit. Submissions queued. Currently running test case 2. It's wrong answer. Okay, none of got here. It's working properly, right? 21 0, 22 and 10. Yeah, I guess we are doing it correct. Actually, our answer is equal to this value. We not initialize it to 0 and then add. We can just select, let's say n into n minus 1 by 2. Here the n value will be reduced. Since we are not using n value again, it doesn't matter if we reduce it. And we will perform only this if k is half, if time is only half of the number of elements. Okay, I guess it's because of int, because it's 10 power 9, right? N and k values are 10 power 9. So here we only took int. Answer value will be more than that. So I'm guessing that's the problem. Now let's submit it. Currently running the test case 2. We only have 3 test cases here. Yeah, it's correct answer. The int was the only problem. So if we refresh here, and now we are left with only 5 questions to solve. I hope we can, today we have solved. Four questions actually, but one of them is actually solved previously, the no drugs question. So only 3 questions were solved today. If we can solve 3 questions also tomorrow, in next 2 days we'll be finishing the no drugs. In next 2 days we'll be solving the greedy algorithms. Then we can jump to dynamic programming topics. Okay, we have only 2 in them. Okay, that's it for today. Thank you.